All right, so we are recording. So, y equals a sine of b times x minus c plus d. Okay? The b part works with the period. How long's a normal period of a sine or cosine function? One period of it. How long do we usually go? 2 pi. So the period is going to be 2 pi divided by b. The period is going to be 2 pi divided by b. So let's say we have y equals the sine of 2x, where this is b. Okay? So let's see how that affects our graph. Well, our period is going to be 2 pi divided by 2. So how long is our period going to be? Just 1 pi. I'm still going to have you graph the normal sine curve and then graph a new one with the period involved today. All right, so my period is 2, so I want to space everything out where I have a number divisible by, pi needs to be a number divisible by 2. So I went 8 on this example, which works because 8 is divisible by 2. So if I graph the normal sine curve, y equals sine of x, I start at 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. Okay, that's nothing different than what we have been doing. Okay, now I have to put and shrink that down so it all fits into pi. So everything is twice as close to the origin or half as far away from the origin. So basically, what this is, what you do is you take the reciprocal of this, and that's how far you go away. So you're going to go half as far away from the origin. Well, what's half of 0? 0. So that stays in the same spot. Y equals 2 sine of x stays in the same spot. What's half of 4 squares? 2 squares. What's half of 8 squares? 4 squares. Half of 12 squares is 6 squares. And half of 16 squares is 8 squares. So that's what the sine of 2x curve looks like. Okay? So that's easy peasy lemon squeezy. Okay? Because it's just half as far. If it's a 2 in front, it's half as far. Where it gets a little more complicated is if you have a fraction there. So let's say we have y equals cosine of 2/3 x. All right, and what I'm going to do is I'm just going to graph the normal cosine curve first. But we have a 2/3 involved. So there's a 3 involved, a 2 involved. So I'm going to go over, I suppose, 6 to get to pi. Just because. So if I graph the normal cosine curve, y equals cosine of x, I start at 1, 0. Looks like this. Now, what's going to happen to my graph? It's going to stretch, right? Because if the period, let's do this in red, the period is 2 pi divided by 2/3. Oh, that's a complex fraction. How do I get rid of a complex fraction? Well, I could multiply by the denominator, right? So my period's going to be 6 pi divided by 2, or my period's going to be how long? 3 pi. So it's going to be all the way out here at 3 pi. It's going to stretch it out a little bit. So what's the reciprocal of 2/3? So I'm going to multiply each point by 3 over 2. So what's 0 times 3 halves? 0. What's 3 squares times 3 halves? 9 halves or 4.5. Oh no, I wound up going halfway in between one. It happens sometimes. Okay? Now, it would have been better if I would have gone 12 squares to get to pi. But I just wanted to show you that sometimes you think ahead and, you might do it wrong. But it's nothing wrong with it. You just go halfway in between. It's good enough. Okay, I went 6 squares. What's 6 times 3 halves? 9 squares. So I need to go 9 squares to get to this point. And here, I had gone 3, 6, 9 squares. What's 9 times 3 halves? 13.5. So I'm at 9, 10, 11, 12, 13.5. Right there. And then 12 squares times 3 halves is like 18 squares, which would be here. So it's just stretched out a little bit more. Okay? We're just stretched out a little bit more. All right. Let's do another one. All right. Let's say we have y equals 2. Oops. I got it right on there so you can see. Y equals 2 cosine of 1/2 x. Okay. What is the 2 going to do to the graph? Stretch it which direction. That's the important thing. That's going to stretch it vertically. What's the 1/2 going to do to it? Is it going to shrink it by 1/2 or stretch it by 2? Stretch it by 2. Okay. So, let me put the graph down. So if it's going to stretch it by 2, I got to be careful when I put out my numbers, okay? Because if I go a long ways to get to pi and 2 pi, it's got to stretch it way over there. So I'm only going to go till 4 to get to pi and 8 to get to 2 pi. Because I know one period goes to 2 pi, so then if I stretch it out twice as much, I'm going to wind up going all the way out to 4 pi. So here's pi over 2 and 3 pi over 2. All right. So I'm going to graph, I should put on my vertical, 1, 2, -1, -2. So I'm going to graph y equals cosine of x. Where does cosine of x start? 0, 1. Then I'm at pi over 2, 0, pi, -1, 3 pi over 2, 0, 2 pi, 1. So it looks like that. Then I'm going to graph y equals 2 cosine of x. This is going to be twice as high, twice as low. And now we're going to do the stretch. Because my period is going to be 2 pi divided by 1/2, or it's going to be 4 pi. So I got to stretch everything out twice as much. So the first green dot doesn't move, because 2 times 0 is still 0. But this green dot goes twice as far away. Instead of being 2 over, it's 4 over. This one, instead of being 4 over, is 8 over. This one, instead of being 6 over, is 12 over. And this one, instead of being 8 over, it's 16 over. So there we are. Okay, let's do one more here. Let's go y equals 1 minus 2 sine of x over 2. Okay, when it's written like this, it's not written in the normal order, is it? I want to rewrite it in the normal order. What would the normal order look like? What would the equation be? Because I want it in the order a bx minus c plus d. So I started out with -2 sine. What's b? I don't want to write it as x over 2. I want to write it as a fraction x. So it'd be 1/2 x. And then what would I write? -1? +1. because this is a positive 1. Okay, now I have it written in the right order. Okay, so what I'm going to graph basically is I'm going to graph y equals sine of x. I'm going to graph y equals sine or negative 2 sine of x. I'm going to graph y equals negative 2 sine of 1/2 x, and so on. All right, so since this is 1/2, does that stretch or shrink the graph? Stretch it. How far does it get stretched? 2. Twice as far. So I'm going to make sure I don't go too far here. So I'm going to go 4 to get to pi again. Pi, 2 pi, 3 pi, 4 pi. 1, 2, 3. Negative 1, negative 2, negative 3. Pi over 2, 3 pi over 2. All right. So I'm going to graph y equals sine of x. Okay. So where is y equals sine of x? Well, we start at 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. The next one I'm going to graph is y equals negative 2 sine of x. What does a negative 2 do to my green graph? Flips it around the x-axis and makes it twice as low and twice as high. So the 0 doesn't move at all. The 1 goes to negative 2. The 0 stays. The negative 1 goes to positive 2 and 0. Okay. Now the 1/2. The 1/2 makes this go twice as wide. So this one still doesn't move. Instead of being over 2, I'm over 4. Instead of being over 4, I'm over 8. Instead of being over 6, I'm over 12. And then 16. And last but not least, I go up by 1. So everything up by 1. We good? Okay. Page 127. We'll do 9 through 15, the odds. That's 4 problems. Generally, I do 2 assignments today. We'll see what we do. Hello. I'm just gonna just cross out the second half because they're okay. Okay. So yep. Yep. So that'll be halftime. Yeah. Right. Right. And then we've got when's senior night for girls? Is that the 16th? Okay, but that's before the game, so that's not a big deal. Yeah. Right. Yeah, exactly. Right, because we still have to set up mats after the game is over. So, yeah. Yeah, just delete the second half and that's fine. All right. Yep. Bye.
So for the last example problem, could you just take 1 minus 2 to get negative 1 sine of x over 2?
No, because this is a multiplication problem, and you can't do subtraction with
operations.
Mm-hmm.
Gotcha.
Mm-hmm.